Okay, so today's date 1/2/3/22. Okay. So what's our objective today? What I'd like to do is I want us to be able to create piecewise functions. Okay. We know that piecewise means really more than one graph. And hopefully we know what a function is now. I mean, this whole f of x thing means it's a graph that passes that vertical line test. 1x for 1y, right? So we know when we see this f of x, we know it's a function. We now know what a function is. We now know why teachers keep using f of x. There's a reason we call it f of x, because it's a function, right? Domain. We've talked about domain, and I'm going to write it down. Domain is the set of all x values and the range is the set of all y values. Okay. Domain's kind of important. You don't write this down at all. I want to show you why domains work. Everything I do in here, I'm going to do my very best to tell you why, because otherwise you just do math for the sake of doing math. There's only one job that you get to do math for the sake of doing math. It's my job. Right? You agree with that? Everybody else has to use math in the real world, right? So think about this. Age, height, right? What's wrong with that graph? Age, height. What's wrong with that graph?
You get older forever. You get higher.
Both, you're right. So eventually you're going to die. So you better just get rid of that arrow, right? And then also you can't have negative age. Ever agree with that? So this is a great example of domain. Domain's only from here to here. We don't know where this is. We're hoping this goes longer than shorter, right? But that definitely domain's important, right? Range is important. Range is important too, because here's from height to height, right? I mean, there are people that are 7 feet tall, but no one's beyond that, right? So that's a great example of why domain and range are important, okay? Now, let's try and do this graph. So you have a piece of graph here, all right? We know we have to graph it, so I just like to start right here. And I'm going to put my XY axis down. Grab my ruler. That's not a very good pen. Find a better pen. Okay. Okay, here's my y-axis. Here's my x-axis. And I'm going to start with the boundaries. This is the way I like to do this. Is I like to start. Oh, I'm looking for the right pen. Wherever it may be. Hold on. The right pen. Oh, no, that's not the one I'm looking for. I'll find the right pen. I will. I am prepared, really. I am prepared. Well, all right, I'll just use it. So, I start here with my boundaries. And so my boundaries are x is less than or equal to 1, x is greater than or equal to 1. So I find 1 on the x-axis. And I'm going to put in an invisible line. When I say invisible, I'm going to draw it in, but it really is invisible. It's not part of the graph, but I like to draw it in anyway, okay? Because that's where the two graphs are going to be separated. So after I draw the boundaries, then the second thing I do is I look at the two equations, okay? So I have two equations. Now we know that f of x and y are the same thing, right? For what we're doing. So my first equation, equation 1, is y equals 2. You see it? fxy equals 2. And my second equation is y equals x minus 3. Now I want to graph both equations. So I'm going to use a pencil because I'm probably going to need to erase. I'm going to do this on purpose. You might want to just wait before you put this line down, but y equals 2 is a horizontal line at 2, all the way straight across, right? Y equals 2, horizontal line 2. But I don't want all of it. I have a boundary, so I'm only going to have part of this graph. The part I'm going to have is, on this one, is going to be where it's x is less than or equal to 1. So my y equals 2 graph is only going to be here on the left-hand side. So 1, I only want less than or equal to 1, so I'm going to erase. I don't need this. And the right hand of the graph does not exist because we only want where it's less than or equal to 1. Now, there's one other thing, and that's right at 1. So I can either put at the boundary line either a solid dot or an open dot. What am I going to do? Is it going to be solid right here or open?
Oh.
Yes. How come?
Or equal.
You see the equal. Nice job, Scott. I totally agree. You guys see the less than or equal to? So at 1, I'm going to put a solid dot. So I'm going to go ahead and make this more permanent. I'm going to use my pen now. Solid dot. There's the first piece of my graph. Okay. Thumbs up so far? Okay, see one thumb up, 2 thumbs up. Any more? 3, 4? Any more thumbs up? Any sideways thumbs? Sideways are okay. Sideways thumbs are okay. All right, Gretchen kind of gave me a wavering thumb there. Now, graph number 2. It's a 1x, right? It has some invisible numbers, 1 over 1. So I'm going to remember my y equals mx plus b, where I know I'm going to have a y-intercept of -3 and a slope of 1 over 1, okay? So I'm going to go to -3 on my y-axis. 1, 2, 3. And my slope is up 1 over 1, up 1 over 1, up 1 over, okay? There's equation 2. However, I've broken the rule. It's not a function anymore, right? I mean, I blew it. I mean, we've got it won't pass the test because I drew the line too long. So I go back up to its boundary. It's on the greater than or equal to 1, so it's on the other side of the boundary. So I'm just going to erase the extra. I don't need the extra at all. So this is what's a little confusing to kids, but not to you because you're smart. Okay, I want everybody to look. Okay, now here's the number one mistake that happens. You see the -3? A lot of kids are going to start on the boundary line at -3, right? Right? So they're going to start here. That's a y-intercept. It's not a boundary line intercept. So we aren't going to start 1, 2, 3. We start -3. Here we just erased it. Does that make sense? It's really easy because, oh yeah, I'm going to go down 1, 2, 3, start here. We're not starting here. We started here and we erased it, okay? Right. I hope that makes some sense. All right, so then draw my line in. And I have one more adjustment to make. What's my one more adjustment to make? Yes, Tava?
Open circle?
Open circle right there. It has to be open because there's no equal sign. Plus, we wouldn't have a function, okay? What do you think? We just graphed a piecewise graph. Can you do it? Okay, so the trick is, go to your boundaries first, draw your boundary lines in, they're invisible, and then graph the lines and decide where those lines exist, okay? All right, now the domain. Here's my graph. Okay, let's scoot this up. Domain. Well, how wide is this graph? It goes forever this way, and it goes forever this way, doesn't it? I mean, think about how wide. I mean, the graph together is one graph. So together, it covers the entire graph, doesn't it? So every possible x value is part of the domain. So we're going to say the domain is x equals all real numbers, okay? How about the range? Don't you hate it when I wait for you guys to answer the question? How about the range? Go ahead, Tava, take a stab at it.
Greater than or equal to negative, or greater than -3.
Nice job. How about 2? But you got the right idea.
Yeah.
Yeah, 2, right? 1, 2. And I like how you corrected yourself. Greater than -2. Nicely said. Good job. So, yeah, Scott, question?
Okay, so how did we get -2 again? Like, how did you plot it there?
Right, great question. Okay, so let's go back to algebra 1. So if I have to graph this line, it goes down to -3. 1, 2, 3. And then to graph this line, up 1 of 1 up 1. Okay, got my line?
Oh, so you just started.
I just started -3 on that. And that's why I brought that up exactly, because that's a very common mistake on these, is to start it here. We actually started here, okay? Now, Tava, correct yourself. Nice job. Here's an open circle there, so it doesn't equal. It does not equal -2, but it goes up from there, okay? All right. Let's turn the page. Let's do the opposite, okay? All right, turn the page. Okay. Oh, darn it. I knew I shouldn't have used that pen, but there it is. Hold on, I'll just get a different sheet. Got lots of these. All right. All right, number 2. We're actually going to make a piecewise graph, okay? We're going to draw a piecewise graph. Again, I can do that. So, this one's a little bit bigger. So, do you remember what's the first thing I told you to do?
Do the boundaries.
Yeah, let's do the boundaries first. So, the boundaries are there. So, let's draw my x-axis in and my y-axis in, okay? Right, x-axis, y-axis, 1, 2, 3, 4, 5. So at -5, I'm going to put a boundary. At -2, I'm going to put a boundary line. And at +2, I'm going to put a boundary line, okay? So I found the boundary lines from here. And I'm going to put them in. They're invisible, right? Remember, they're invisible, but I'm going to draw them in anyway. So I got a boundary line at -5, boundary line at -2, and a boundary line at 2. All right? So f of x and y are the same thing, except for it's specifically a function. So now I have 3 equations, right? My first equation is y equals 4. That's my first equation, y equals 4. My second equation is y equals x squared, okay? And I'm going to help you graph the x squared, okay? And my third equation is y equals x plus 2. All right? Hopefully I'm not going too fast for you. Now, let's see what we got. Am I doing okay? Am I going slowly enough? So y equals 4 is a horizontal line all the way across at 4. So, I mean, normally I would just draw it in, but I'm not going to draw all of it because it's stuck. It is stuck between -5 and -2, right?
So I'm only going to draw in the part of this graph between -2 and -5 and 2, so I don't really need all the rest of this, just, you know, waste of pencil lead. So I draw that in, okay? Now, tell me about the endpoints. Tell me about the endpoints. At -5 on this graph, graph it in, tell me the endpoints. Solid or open, right here. Is it solid or open?
-5.
Right here, -5.
Solid.
Solid, because there's an equal. See the little equal? That's an equal sign. So it equals 5. How about a -2? Solid or open?
Is that open?
Yes, because there's no equal, so it does not equal that point. Now y equals x squared. Now you haven't seen a lot of this, and we are going to see a lot of this. The big, probably half our chapter or half our class in here is going to be about these kind of graphs. Okay, so I want to introduce it to you. So if you don't know what it looks like, let's go to Desmos. Okay, I'm going to show you what it looks like. Okay, if I go to Desmos and I go y equals x squared, it's a parabola. Okay, so y equals x squared is a parabola. And the parabola are just squared numbers. Right?
It's going to be easy. Listen. Listen, listen, listen. What's 1 squared?
1,
2 squared?
4,
Good. 3 squared? Awesome. What's -1 squared?
1.
Positive 1 because a negative times a negative. What's -2 squared? Positive 4 because a negative times a negative. What's -3 squared? So if I went, watch my finger, everybody watch, 0 squared,
0,
I'll put it out there. What's 1 squared?
1,
I'll put it out there. 2 squared. 2 squared?
4,
1, 2, 3, 4. See how this works? -1 squared. -2 squared. Okay, let's put that in, okay? So, and then we saw it on Desmos, so we know what it looks like.
Again, if I go back to Desmos, we know it has to look like this. So we know it's that graph right there, but there's an easy way to put this in because we know that 0 squared is 0, 1 squared is 1, 2 squared is 1, 2, 3, 4. -1 squared is 1, -2 squared is 4, and then it keeps going, but I don't need to graph all of it because we know that this parabola exists between -2 and 2, so I'm just going to graph it in, okay? Kind of curvy, it's got this nice curve to it, okay? Right? So, at -2, it's an open circle, but now we're going to close it. Does that make sense why we're going to close it now? So at -2, it's open, but now we're going to close this dot. Okay, so we close it. Okay, and then at +2, we're going to have it open or closed at +2. We're going to have it open. Okay, good. All right, there's my graph. Awesome. Let's look at graph number 3. So graph number 3, and Scott, this can help answer your question. We're going to start at 2. Okay?
But we start at 2. You're watching? We do not start on this line. This is not here. This is an invisible line. This is just an invisible line, right? We start at 2 there. That's the y-intercept. Do we agree with that? This is an invisible line. Don't start here. Start right there on the y-intercept. Okay? So we start at 2.
And even though we're going to erase it, I'm going to start at 2 because it has to be in the right place. And I'm going to go up 1 over 1, up 1 over 1, up 1 over 1, okay, and so forth. Okay. Now I don't want to draw the whole line in because it really only exists greater than 2. So I'm going to draw it in like this. Now, right here at 2, I have an open circle, but now I'm going to close it. I'm going to close it because I get an equal. And there's my graph. They do connect. They don't have to connect. I always like it when they do. It's kind of cool when they connect and you make one graph that's all connected and makes one graph together, right? So, domain range. Domain. Domain.
Greater than -4.
X, 5, but yeah, you're right.
5.
X is greater than or equal to -5, okay? Thanks, Tava. So we start at -5. See what she did? So how wide is it? Well, there's nothing back here. There's no graph back here, so it starts at -5 and goes forever that way. Thanks, Tava. Range. Reach for your range. What's the very bottom point? Reach for your range. What's your very bottom point? 0, right? And then it goes up, right? How far does it go up? Forever. So we're going to say y is greater than or equal to 0, okay? Okay, y is greater than or equal to 0. Okay, so that's what I have. Homework today is out of your journal again. It's going to be page 10 and 11, and we're going to do 10 through 16 all, okay? And I might help you with one of these, but let's get you started anyway, okay? We got lots of time, so when I say homework, we got 25 minutes, right? We got lots of time. Okay.